Hi, welcome to Full Steam Ahead New Jersey. I'm Miss Lee, and today we're going to be working on our straw rockets. So before we get to actually building our straw rocket, I wanted to go ahead and do a little bit of background about how spaceships or rockets fly. So I'm going to share a couple pictures and a little video clip with you guys so we can sort of examine some of the science behind it briefly. Here we go. So we are looking at rocket ships and how they launch and what helps them fly. So there's always a nice countdown. There's a lot of commotion. It's very loud. There's some explosions that come out. So let's look at why all that happens. So if you were to look at the shape of a space rocket, you would see that it always comes to a point at the top. So right here, this is called the nose cone, and that helps reduce air resistance. So it helps the ship basically cut through the air so that the bigger portion of it can follow through a little more easily. So if you've ever gone swimming in a pool, think about the nose cone almost like if you're diving. You put your fingers out in front of you to protect your head and the rest of your body. It breaks the surface tension of the water. If you compare that to trying to go ahead and doing a belly flop, where like a lot more of your surface area is hitting the surface at once, it's a lot tougher, ends up being a little painful. So that's why a rocket is shaped the way it is, to cut through the air and cut down on that air resistance, as opposed to the pool, it's water resistance. Okay, inside, you're going to find fuel, so like the way you would put gas in your car. And there's also something called an oxidizer. So that adds in oxygen. When you mix fuel and oxygen and you add a little spark, you get an explosion. So we're going to call that combustion. So there's a combustion chamber down towards the bottom that helps to control and manage that explosion so that when the fire comes out, it helps power the rocket ship. So for every action, there is an equal and opposite reaction. So when the fire or explosion is coming out of the bottom of the rocket, it's pushing down against the ground and the platform, the launching platform. And with an equal amount of force that it pushes down, that platform is pushing back up against it. So the harder the force going down, the stronger the force going up. And that's going to just help that rocket take off. And in a little bit, we'll watch a real spaceship take off. But we'll look at another example of how this force and equal opposite reaction works is if you guys have a balloon in your kit, which you should, I want you to take a second and blow it up, but don't tie it off just yet. Good. So you can just kind of twist it or pinch it and hold it. So let's think about if I were to let this go, let's make a prediction. What's going to happen? Is it going to sink? Is it just going to go float to the top? Is it going to fly around like crazy? So once you have your balloon blown up, I want you to let it go and try. So it definitely goes up to start, and then it kind of wiggled around a little bit. So that's the same idea, except instead of like a combustion and explosion, we have air coming out. So all that air I had stored in the balloon pushed down, and as a reaction, my balloon went up. And then as the balloon got a little floppy, it pushed the air in different directions. So that makes the balloon kind of zigzag and go crazy towards the end. But that's the same exact type of force relationship that you're seeing in a rocket when it takes off. So let's take a second to look at a real rocket ship taking off. Oh, I can't skip the turtle. This was just another example of you could see the force coming out of his rocket, and it's pushing him in the opposite direction with an equal amount of force. So obviously this is like a little fake version. I wouldn't recommend doing this to a real turtle, but you can see it even has a nose cone to help it cut through the air. So now let's watch a real rocket take off and take notice of the shapes of the rockets that are helping to launch it. And you'll see all the fire and combustion.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis on the mission to build, resupply,
So they're on their way to the space station, which orbits around the Earth, and they do some research there. So now what you guys are going to do, you have a printable PDF that looks like this, and you have a straw in your kit. Your straw is actually clear. I used a dark one just so it's easier for you to see on the video. But you can choose whichever rocket you want. I gave you a color one or one that you can color in yourself. So that's kind of really up to you. And then there's also a rectangle. So I've already cut mine out. So I'm going to use the one I don't have to color. So I already have this one. And with the tape in your kit, I want you to make a little loop of tape and stick it to the back of your rocket and just put that aside for now. The next thing we're going to work with is your rectangle. You're going to take your rectangle and roll it lengthwise into a tube and secure it with a piece of tape. So your tube, it only has to be big enough to fit over your straw. So your straw is smaller than mine, so your tube doesn't even have to be this big, but it can be. As long as it fits over the tube or your straw and it doesn't get stuck, it's perfect. So once you have a tube, secure it with tape, and then you're going to fold over one end and secure that with another piece of tape. So while you're doing that, I'll just show you again. You'll have your straw. You take your rectangle, you fold it long ways into a nice tube that fits over, and then you fold one end over. So you have like a little cap, and this should fit pretty nicely on your straw without having to push it down too hard. Then you're going to take the rocket that you set aside, use that loop of tape, and stick it to the tube, not to your straw. So this is now one piece, your rectangle and your rocket ship, and your straw right here, and they should fit over each other. So feel free to pause it here if you need to go back and finish those steps. But once you resume, all you have to do to make your rocket ship take off is you are going to blow into the bottom of your straw. It's a bendy straw, it's a little easier. If it's not, you kind of have to bend your head a little bit like mine. So you're going to blow in it like you're blowing out birthday candles. You have to give it a good force. There you go. And you're going to get your rocket ship to take off. So what I want you to do a little bit is once you have it taking off really well, try launching it from different angles and see how you can get it to go the furthest. Or if you want, you might work a little better outside. See how high you can get your rocket to launch. Okay, if you have a brother or sister, maybe you can each make one, like print out both of them and kind of have a little competition with them. The only thing I can think of as far as troubleshooting, if you're blowing really hard and it's not taking off for you, let me grab mine. The reason might be that air is escaping the top, because when you're blowing, you want the air to hit the top of this tube, and that's what's going to force your rocket to take off. If the air is finding a way to go through, your rocket's not going to take off. So that's just a little troubleshooting. You might have to test it and blow into it a little and see if you can feel air coming out. That might be a reason it's not launching. So you might just need to secure it with a little bit more tape. You have a whole roll of tape in there, so you guys can use as much as you need on this. Okay, and there is your straw rockets. Don't forget to experiment a little bit with different angles and heights, or you can even have a launching competition. Okay, thank you for joining me and have a good day.